Hello guys, so the topic of this video is skin effect in transmission line or conductor. Okay, it's one of the very important topic in power system or in electrical engineering. So in this video we'll see what is skin effect and how does it occurs, how to prevent this skin effect means or how to reduce this, okay, and disadvantages. Okay, so you can see here in one figure that this figure, okay, that is skin effect. Okay, from the name we can see that skin effect, we know skin is the outer part of our body. Okay, so something is affecting our skin means something is affecting the outer part. So okay, so skin effect, if we go to the definition, then skin effect in electricity is the tendency of alternating high frequency currents to crowd toward the surface or to flow near the surface or skin of a conducting material. Means what it's actually is, saying is that if we in a conductor, suppose this is one conductor, if current follow through it, then the current try to uh, follow through the outer surface, okay, through the outer surface of the conductor. So that is called skin effect. Here you can see in this figure clearly, this is the cross section view, this cross section view, okay, this cross section view is this figure. Okay, you can see the in the outer surface side of the conductor, the density of current is more than compared to the center part. Okay, current density, you can see this outer surface, in the outer surface it's more, but in middle surface it's not that much. Okay, so this is skin effect. So why does it occurs or how does it occurs? There are so many reasons. Maybe I will see different types of explanation, but okay, we'll just first of all we'll understand it basically theoretically. Okay, the conductor is made of different layers. Okay, here you can see in this figure a conductor is made of so many different layers. Okay, we have divided here different types of layer, and this is the core part, this is the outer part, okay, of the conductor. Create magnetic flux when current flows. Okay, when current flows through this conductor, or here this conductor. Okay, when current flow this through this conductor, it creates magnetic flux. Okay, for every layer. Okay, all the layers create magnetic flux, and flux linkage is more in the middle area. This flux linkage is more in the middle area, this middle section. In the middle section the flux linkage is more. Okay, so that increase the impedance Z, that increase the impedance. That's why current try to flow throughout the outer part, because the skin part or outer part the impedance is low, and current always try to choose low resistance path. You know, that is very slow resistance, current will choose that part. Okay, so we know for this one Z is equal to R plus XL. We'll understand these things in later within this video. with equations, so that you can understand it better in a better way. Other than this flux, this increase flux linkage, other than this explanation of flux linkage, maybe you will see eddy current. Eddy current explanation, okay, for this skin effect. So we'll just talk a little bit about that one. We'll make one cross section of one conductor, okay. Suppose current following through this area. Okay, this is the conductor. I think it's clear. What happened in that condition? If you go for that explanation, this is conductor. Current is flowing through this direction. In that eddy current condition, what happened? Eddy current follows through this direction. So you can see here is that when current is flowing through this direction, in the middle part, the eddy current is resisting this current direction, okay. Eddy current is following through different direction, this direction. For the other side also, eddy current is following through the different directions, but the skin side or outer part of the, this is the inner part, okay, but at the outer part, this is actually physics of this, okay. Outer part, it's this eddy current is following through the same direction current is following, okay, this direction outer part. Here also same, this direction is the direction of eddy current is same with the eddy current, okay. Eddy current is following through same directions, and the in middle part eddy current is trying to resist this current, okay. So that's why current try to flow throughout the outer part, okay, throughout the outer part. We'll understand in the next slides nicely with the equations. So when you know if the V is constant, okay, the V means voltage. If the V is constant, then I, if you don't know this equation, I think you know this is I is directly proportional with the impedance 1 by Z. It's not directly proportional, inversely proportional. So 1 by Z. I is directly proportional with 1 by Z. So inversely proportional means impedance. Okay. That means if Z increase, then I will decrease. Okay. So impedance equation for AC current, you know, Z is equal to R plus XL. Z is equal to R plus XL. R is the resistance that is constant always. R always, we know resistance R is always constant because R actually depend on the material type. Okay. Material type. Conductor material type. Okay. Depend on this. R depend on material type. So suppose one conductor is made of same material, so the resistance for each layer or each section of the conductor is same. So now okay, let's clear this also. R is equal to, this is also good, one important equation you must know. R is equal to rho L by A. that is resistivity into length of wire by area cross section. Okay, this equation we need to know, because from this equation we can say that what are the things that is affecting this skin effect. Okay, this cross section area equation, this also affect R, so this also indirectly affecting skin effect, where rho is equal to 1 by 5 means 1 by conductivity, that is. So resistance is, it's a basic things, but we'll again go through all this, because this is, I'm trying to go full basic. Okay, trying to start from full zero level to, we are trying to understand it. So resistance ratio of voltage and current, and resistor is the device that creates resistance, and resistivity is the material dependent property. Okay, so reactance here, XL, that is impedance, is equal to R plus XL. XL, that is reactance. Okay, this reactance, we know the equation, that is XL is equal to 2 pi FL. Okay, XL is equal to 2 pi FL, and 2 pi we know it's constant, it's 2 pi constant. 2 pi value is approximately 3.14 or 22 by 7, I think you know. And F is constant, F also constant. Actually, in ideally it's constant. In India, F or frequency value is 50 hertz. Okay, L, that is not constant, it's a varying quantity. Okay, so we are talking that one, magnetic flux linkage, magnetic flux linkage and magnetic flux. Okay, actually what happened here in this mid layer, means when current flow through this conductor, it creates magnetic flux. Okay, because of that, magnetic linkage is also there. So at in other than eddy current theory, there is one more theory that magnetic flux linkage is more in this middle part. Okay, magnetic flux linkage is more. You know, when current flows, it create magnetic flux. Okay, so magnetic flux linkage is more in the middle part. That's why it try to flow through the outer part or the skin part of the conductor. So magnetic flux linkage uh, and magnetic flux, uh, and the relation with the L is equal to n phi by I. Okay, L is equal to n phi by I. We can write it psi by I, and flux. So we can say flux is directly proportional to inductance. Inductance means this L. Okay, so we can say flux is directly proportional to inductance. Flux is directly proportional to inductance. Flux, this. Okay, that is why we are saying that when flux is more at the middle part here. Okay, this middle part, when flux is more, that means XL is more. Okay, flux is more means impedance is more, because Z is equal to R plus XL, and R plus XL. So Z is increasing, that means I will decrease, because we know it's inversely proportional with one by with Z. That's why at the middle part, current is current density is low. It try to follow through the outer surface of the conductor. Okay, you can understand this with one table. nicely. Look here. For inner layer and for outer layer. At first, magnetic flux increase, outer layer magnetic flux decrease. Okay, this is one of the theory for the skin effect. At first, inner for inner layer, when magnetic flux increase for inner layer, then because of that, magnetic flux linkage also increase. From the equation, we can say, na? L is equal to n phi by, so n phi is equal to psi. That means this ball, that means n phi is equal to psi. So if phi increase, that means psi will increase for inner layer, we are saying. Then if phi increase, that means L will increase. Okay, magnetic flux increasing, so L will also increase. If L increase, then XL also increase. If L increase, if L increase, then XL also increase, because XL is equal to 2 pi FL, and other three 2 pi and F, other three are constant. L is varying. Okay, if L increasing, say no, XL increasing. If XL is increasing, then Z is also increasing, because we can see here, if XL is increasing, so Z will also increase here. At first upside equation, you can see, because Z is equal to R plus XL, where R is constant, R plus XL. So Z also increasing. If Z increase, then we can say I is decreasing. Here, if Z is increased, then I is decreasing, because I is inversely proportional with Z. I is equal to 1 by Z. Okay, for the inner layer. So for the outer layer we are saying flux linkage is less. Okay, flux linkage is less for the outer layer. It's outer layer. So phi is decreasing. That means if phi decrease, here if phi decrease, so psi also decrease. Okay, means magnetic flux. If magnetic flux decrease, then magnetic flux linkage also decrease. If magnetic flux decrease, then L also decrease. Okay, and if L also decrease, then XL also decrease. L also decrease, XL also decrease, because XL is equal to 2 pi FL. No, then if Z decrease, now if XL decrease, then Z also decrease. If XL decrease, then Z also decrease. And if Z decrease, that means I will increase. So finally I is increasing. Here I is decreasing, here I is increasing. Is it clear? I think. Is it clear or not? All the equations are here. Okay. For phi, look, for phi, here n phi is equal to psi. So phi is increasing. We'll go to this table once again. If you have any doubts, we'll just clear. If phi increase, here phi equation n phi is equal to psi. So psi will also increase magnetic flux linkage. If magnetic flux linkage increase, then L will increase. Here we can see L is equal to sorry, n phi by I, or psi by I. Okay, so L increase. If L is increase, XL will also increase, because XL is equal to phi FL. Then if XL increase, then Z will also increase. If XL increase, from the equation we can see Z also increase. Okay, because Z is equal to R plus XL. So if Z increase, then I will decrease, because inversely proportional. I is inversely proportional with Z. For the outer layer also same. For outer layer, if at first, if magnetic flux decrease, magnetic flux is decreasing, this one. So this psi will also decrease. Okay, because psi is equal to n phi, so psi is equal to also decrease. Psi will also sorry decrease, that is magnetic flux linkage. If psi is decreasing, then L will also decrease. Okay, L will also decrease because L is equal to psi by I. L is equal to psi by I. Yeah. So interesting logic and good thing, means easy things also, but you just need to remember only few, two, one, two, three, four equations. That's all. Very easy. Three equations only. Okay. So if XL is XL is decreasing means reactance is decreasing. Reactance is decreasing means impedance is decreasing. Impedance is decreasing means this Z is decreasing means I will increase. Okay, because 1 by Z value will become less. Okay, or you can say I is inversely proportional with Z. So that's it. So this is the reason you can say for a skin effect. Okay, because of this skin effect is occurring in transmission line conductor or conductor. So it, one of the good very important thing is it only occurs in AC current, because for DC, this one is frequency AB0 is equal to for DC. For DC, we know there is no frequency, F is equal to 0. So if we put F is equal to 0 in this reactance formula, XL is equal to phi FL. So this total part XL is equal to, it will come 0. This is for DC. Okay, this will come total 0. So XL part will be 0. So Z is equal to, for DC it will come Z is equal to, it will come R. R we know that is constant. Okay, resistance that is constant for conductor, because the conductor we are assuming it's made of same material. Okay, so this skin effect only occurs in AC current, when AC current follows through the transmission line conductor or through any conductor. Okay, so how to reduce this skin effect? There are so many like ways. We just try to go with only few. There is one, use standard wire. Okay, not standard, sorry, stranded wire. Okay, standard wire. We'll see what is standard wire. Standard wire is this one, bundle, or we can say just bundle wire. Okay, made of so many bundle. Okay, so many wires, made of so many wires. It's not one solid wire. Okay, so many small wire there is. Okay, so that is called stranded wire. Stranded wire. Okay, and there is one more, reduce the thickness of the conductor. Okay, reduce the thickness of the conductor. Thickness, if we reduce the thickness means A, cross section area, R is equal to rho L by A. We have seen rho L by alpha, or A it was. So suppose A is the cross section area, so we are saying that one, sorry, A is the cross section area of conductor. So if we reduce the cross thickness of conductor, by doing this also we can reduce the skin effect. Okay, and factor affecting skin effect from the from those three equations, we can directly say skin effect is directly proportional to frequency and proportional with the thickness of conductor. Okay, because Z is equal to 2 pi A L, so it's proportional with the frequency skin effect, because Z that I is equal to 1, I is proportional to 1 by z, that same equation. And with the thickness rho L by A, R is equal to L, rho L by A from that equation, and directly proportional with the diameter of the gun, same thing with the diameter of conductor, and directly proportional with the temperature of the conductor. This also temperature also one of the constants for this. Okay, so we'll go to that slide. Try to go to that slide. Okay, sorry for that. And we'll see the disadvantages of skin effect. Disadvantages of skin effects are it can voltage regulation will decrease. Okay, copper loss will increase voltage drop, and low efficiency and generate heat. Okay, these are the some common disadvantages of skin effects. So if you have any doubts, please comment in the comment box and subscribe this channel. uh, I'll try to make videos on your doubts surely, and it is my humble request to everyone, please plant just one tree each Sunday. Okay, you can, maybe if you are from India or if you are from anywhere place, you can see that global warming is affecting us everywhere. Okay, so the only way to fight against global warming is plant trees. So it is my humble request to you, to my viewers, subscribers, that just plant only one tree in each Sunday. Okay, that's it. You don't need to plant every day. You just do it on a holiday, on your holiday, just only one. That will help everyone. That will help you. That will help everyone. Thank you guys. So that's it. Bye bye.